Okay, calculates. So, still talking about differential equations, which we've been doing a lot of in this chapter, and just kind of a recap that, of course, we are splitting up or separating the variables. So, we're getting all the x's on one side, all the y's on the other, so that we can have a dy on one side, a dx on the other, and then we can actually integrate. And then after we integrate, we'll get y by itself, so that we'll have the equation of our function. And then, of course, for the general solution, it will have c in the answer. Now, if we want to get to a particular solution, we'll need an initial condition so that we can solve for c. And we'll do the exact same thing as we did in the up above. So still following all of this stuff, except this time we're going to plug in that initial condition, and then we can solve for c. And then, excuse me, keep in mind that some differential equations will actually have a unique solution. But not all of them. And as a new terminology, the order of my differential equation is determined by the highest order derivative. And I think of this very similar to trying to decide the degree of a polynomial. So on a polynomial, I look for the highest exponent. In this case, I'm looking for the highest derivative. So, for example, if we had this equation, then it would be the first order of the first order, because the highest derivative in it would be the first derivative. Versus if I gave you something that looked like this, then this one would be a second order differential equation, because the highest derivative in it would be the second derivative. So just some new terminology.